This video is the continuation of the partial estimation of concrete works for a bungalow project. Welcome to Quantity Surveying. The project is a bungalow-type residential building with 3 bedrooms. Instead of the structural details illustrated, the specifications are as follows. The columns are square of 400 mm size. The roof beams are identical with 300 by 350 mm dimension. There are 12 units of 800 mm square isolated footings with depth of 450 mm. The embedded column is 1 meter. The floor-to-floor height is also identical with 3 meters. For the openings, the entrance door is 1 meter with double door. Room doors are 0.9 meters with panels. The T&B and laundry doors are 800 mm width. The receiving room has 2 pairs of 0.8 width by 1.2 meter height of sliding windows, whereas the dining room has 2 pairs of 1 meter width sliding doors. The kitchen has 1 pair of 0.6 by 1.2 meters height sliding window, and the rooms have 2 pairs of 0.6 width by 1.2 meter height sliding windows. The first task is to estimate the masonry works for bedroom 2 using 5 inches CHB for both partitions and walls. It is instructed to provide 2 layers embedment. Estimating masonry works with computing areas, and to determine areas, length and height are required. For the height of both the wall and partition, consider taking the specification of a floor-to-floor height of 3 meters. This means that 3 meters consists of the wall and the beam. However, the beam has a depth of 0.35 meter, so the clear height of the wall from the natural grade line is 3 minus 0.35, which gives 2.65 meters. There is also an embedment of 2 CHB layers to the wall footing. Thus, the wall has additional height beneath the grade of twice of 0.2 meters, giving 0.40. So the total height of the wall or partition is 2.65 plus twice of 0.2, resulting to 3.05 meters. After learning about the height, compute for the perimeter of the wall. Bedroom 2 has on-center dimensions of 3 meters by 3.5 meters. Focusing on the vertical walls, the clear span is computed as 3.5 less twice of half of the columns. That is 3.5 meters minus twice of half of 0.4 meter. The length is solved as 3.1 meters. So the total length of 2 walls is twice of 3.1, which is 6.20 meters. For the length of the horizontal walls, do the same procedure of taking the clear span from the on-center distance of 3 meters less twice of half of the columns on both ends. That becomes 3 meters minus twice of half of 0.4 meter, which becomes 2.6 meters. The total length of the horizontal walls is then 2 times 2.6 meters, which results to 5.20 meters. From here, we can take the perimeter of the wall as 6.2 plus 5.2, which becomes 11.4 meters. To compute for the area of the wall, we take the gross area by multiplying the total height of 3.05 meters times the perimeter of 11.4, which results to 34.77 square meters. Subtract the openings of the bedroom. There is a door opening with width of 0.9, and using standard door height of 2.1 meters, we take the door area as 1.89 square meters. Another opening is the window, which was specified as 2 pairs of sliding windows with 0.6 meter width. 2 pairs mean 4 panels of windows. So, have 4 times 0.6 meters width by 1.2 meters height, giving the area of 2.88 square meters. Now compute for the net area, which is taken from 34.77 minus 1.89 minus 2.88, giving 30 square meters. So the number of CHB is computed as 12.5 blocks per square meter times 30 square meters, resulting to 375 pieces. To solve for the mortar of the wall, separate the computations for filler and block laying. Starting with mortar filler, it is easier to use volume method as the number of CHB has already been determined. With each CHB having 4 voids, and each void is measured from 3 inches by 3 inches by 8 inches, or that is 0.001125 cubic meters. Take the volume of mortar for each CHB as 4 times 0.001125, which accounts to 0.0045 cubic meters. Thus, the volume of filler is 375 pieces of CHB times 0.0045 cubic meters per block, giving 1.6875 cubic meters. The other mortar computation comes from block laying. With no given tables for area method, work on this factor using volume method. This technique requires the number of layers and the dimension of each layer to know the total volume. First, determine the number of layers by direct counting. Start with the horizontal walls, which give 5.2 meter length. From the 2.65 meter height above the natural grade line and the 2 layers embedded before the wall footing, lay out the number of layers. Check out that after the topmost CHB layer, the total height is just 2.6 meters, which means that there is a 0.05 meter or 2 inches gap to the bottom of the beam. From the top of the wall footing to the topmost CHB, there are 15 layers. The volume of the block laying for the horizontal walls is then determined from 15 layers of 5 inches or 0.125 meter wall thickness times block laying thickness of half an inch or 0.012 meter times the length of 5.2 meters. Then add the topmost layer of 2 inches thickness, or that is 0.05 meter times 0.125 times the length of 5.2 meters. The volume for the walls is then computed as 0.1495 cubic meters. Now solve for the volume of the exterior wall. This is the wall with a 1.2 meter high window. By reflecting the window to the wall, there are 5 layers of block-laying mortar which were affected, meaning they have shorter lengths. The length is taken as the on-center distance of 3.5 less twice of half of the columns on both ends, minus the 2 pairs of 1.2 meter width of the window. The length of the wall on these layers turned out as 0.70 meter. So compute for the volume of block laying as the 10 layers of original length of 3.1 meters times 0.125 and 0.012 meters plus the top layer with 2 inches thickness times 0.125 times 3.1 meters. And the 5 layers of window layers times 0.125 times 0.012 by the length of 0.70. This results to 0.071125 cubic meters. The opposite vertical wall has a door opening. So using the complete number of layers, reflect the door opening with a standard height of 2.1 meters. This will then affect 10 layers, making the length of the layers shorter. The shorter length is measured as the on-center distance of 3.5 minus twice of half of the columns minus the width of the door. That is 3.5 minus twice of half of 0.4 minus 0.9, resulting to 2.2 meters. The volume is then determined as 5 layers of 0.125 times 0.012 and 3.1 meters for the whole lengths. Then add the topmost layer with 2 inches thickness times 0.125 meter with 3.1, and then the shorter layers are included as 10 layers of 0.125 times 0.012 times 2.2 meters. The volume is then 0.075625 cubic meters. Take the summation of all volumes for block laying. Those are 1.6875 plus 0.1495 plus 0.071125 and 0.075625, which results to 1.98375 cubic meters. By using Masonry mixture B, the cement quantity is then the volume times 12 bags, which then becomes 23.805 bags. Sand is then 1.98375 times 1, becoming 1.98375 cubic meters. The other task is to estimate the plastering in both faces of the facade where the patio is disregarded. Illustrating how the front view of the structure looks like, there are 2 bays, one of which is 3 meters and the other has 4 meters span. The height will be considered as the floor-to-floor height of 3 meters as the patio is disregarded. So the clear height of the wall for plastering is 2.65 as the beam depth is to be subtracted. So continue the computation by taking the total length of the wall. That is 3 plus 4 less twice half of the 2 columns at the end and the width of the middle column. In numbers, that is 3 plus 4 minus twice of 0.4 over 2 minus 0.4, which gives 6.2 meters. The area of the wall is then the 6.20 length with the 2.65 meters height less the door opening, which is twice of the 1 meter width double door times 2.1 meter standard height. That gives 12.23 square meters. From the instruction that plasters for both faces, the total plaster area then becomes twice of 12.23 square meters, which is then 24.46 square meters. Incorporating the standard thickness of 16 mm, the plaster volume becomes 0.39136 cubic meters. So using Masonry Mix B, cement is then a volume of 0.39136 times 12, which is 4.69632 bags. Sand is then 0.39136 times 1, giving 0.39136 cubic meters, just the same.